And we're back in the studio. So today we're going to do something a little bit different. We're not going to be in the field. We're going to talk about heat exchangers and the different types and what to look for and what they do. So here we go. So what do heat exchangers do? What's the whole purpose of them? Well, one of the most important things is they keep the exhaust gases and the heat separated from the airstream. So you don't want all that flue gas getting into your airstream and blowing inside the house, because then it's a hazard. We don't want to be breathing in that stuff. We just want the heat off of it. So the heat exchanger will isolate all that heat and gas from the actual airstream of the air going inside the house. Right? So how that works is you basically have a metal box. You'll have some type of burner in there. It's going to burn inside the box and then exhaust through a flue pipe. Right? And that's completely separated from your airstream. And the heat exchanger is basically that metal box. It's going to get hot as that air coming in from your return touches that hot box. It's going to absorb some of that heat. It's going to exchange the heat from the heat exchanger into the air and then go into the house and warm up your home. That's pretty much what the heat exchanger does. If you don't have one, your heater's not going to work. There are different types of heat exchangers. There's the original style, which was off of a natural draft furnace. It didn't have an inducer. Basically, it was literally a campfire in a metal box. So basically you have barbecue burners in there, and it would light up, and the heat would just rise naturally. That's why it's called natural draft, because it creates a natural draft. I'm going to show you a chart of how one of those work. So as you can see here, the natural draft furnace basically has the burners. It has a burner or a burner ribbon, and basically it's going to light up, and that heat is going to rise up, and it's going to be heating up that heat exchanger. Now the blower motor, you can see on the bottom, is going to be pulling air from the return. It's going to go across those clamshell heat exchangers. That's the style that they used for natural draft furnaces, is a clamshell, because basically it's just two pieces of metal like a clam shell, right? And put them together, boom, you got a heat exchanger. So you can see there that those ribbon burners right there would burn, and you would have that heat rising through the heat exchanger. Now you see where it would exhaust, and then you'd have that draft hood, and that's just so the heat would actually rise, and what it does is it'll actually pull a little bit of cool air in there, and that's going to help prevent any backflow, any of that exhaust coming back through there. And then it would just naturally rise, and that heat exchanger exhaust, or that exhaust for that particular type of heat exchanger is very hot. So you would see them using either a metal flue, which would be a double wall, but was actually really common was they'd use a transite pipe. So that's that white concrete looking pipe. Basically it's just compressed asbestos. It's not like 100%, it's a mixture of other stuff. You'll have to look that up online. I'm not sure exactly what the mixture was, but it kind of looks like a white concrete pipe. And the reason why is because it was a great insulator. So if it touched any wood, you didn't have to worry about it getting so hot it would cause a fire, because that exhaust off of a natural draft furnace, that temperature, it's really high. So be careful if you see one of those. If you see like a single wall hooked up to that, don't touch it, because it will burn you. Those things get really hot. I forget exactly what the temperatures are, average temperatures for the exhaust for those, but they're pretty high. And then you have the newer style. The temperatures are still pretty high, but they're not quite as high as that. And that's just because what ends up happening with the natural draft furnace is about 60% of all the heat it produces goes into the home. It transfers into the airstream. The rest of it is pretty much going out through the flue. I know you guys are going to say, oh, well, that's the AFUE, the annual fuel utilization efficiency, I think is what it stands for. But realistically, what it is kind of a measurement of how much heat you're putting into your home throughout the season. But basically, it's a good, I guess, I wouldn't say it's a exact guide, but pretty much about 40% of your heat's going out the flue, because it's got to suck it up from the heat exchanger. But because of the style of them, it's literally just got a ribbon burner in a metal box, so it's just not very efficient. They were some where they would go hybrid. They basically throw a inducer on a clamshell heat exchanger, and that would help a little bit. And then they would also, you know, put like divots and different stuff to kind of expand the surface area to transfer a little bit better. But that's when they basically were like, we need to redesign it, and they came out with the 80%er. And why is it 80%? Well, 80% of that heat that it produces pretty much goes in the home, 20% is going out the flue. So that's a drastic improvement. Also, if you want to consider fuel utilization, it's going to be using less fuel to produce the same amount of heat as an older furnace. So there are efficiency things, there's a lot of calculation I'm not going to get into, but basically that's a good way to kind of understand, you know, where they go. But anyway, right here we have a heat exchanger. This is actually going to be a serpentine. This is off of a Carrier unit. So you got your burners down here, and this is going to be for 80%er, so you always have your burners on the bottom, assuming it's an upflow. So this is going to be upflow configuration. So you're going to have burners on the bottom, inducer on the top. It's going to burn on the bottom, inducer is going to pull it through the heat exchanger and out the exhaust. Now you can see this is pointed down because this was a downflow. So if it's a downflow, basically you flip it upside down. But that's pretty much how you can tell. So we're going to go over the types of heat exchangers now. There's basically the three major types. There's the one I mentioned already, which is on the natural draft furnace. That's called the clamshell. Then you have what's called the serpentine. So let me show you what a serpentine looks like. So this is a serpentine off of that Carrier. So they're all slightly different, but they all basically follow the same principle as far as design goes. These are probably the more common heat exchangers you're going to see, just because for the manufacturers they're a lot easier to mass produce, and they're pretty solid. I mean, for the most part, if you have a good install, they're not really going to fail unless they're like extremely old or you have some kind of external force that's causing them to fail early. But basically down here, this is where your burners are. So your burners are right here. It's going to shoot your jet of fire through here, right? And this area is considered the combustion chamber, because this first chamber, that's where pretty much it's combusting. That's where it's shooting in your flames. And then it's going to make a big U-turn here, and then another U-turn, and then another U-turn. Now you can see here that this one starts off as one tube and it splits off into three. That's just an efficiency thing. Not all of them do that. Some of them will just be straight one tube the whole way. But you know, different manufacturers, they're trying to, you know, maximize the amount of heat transfer as possible. So what ends up happening is near the bottom, where the blower is, it's going to be below this. It's going to absorb the most heat into the air. So by the time you're getting up to the top, you've lost quite a bit of heat, and that's just because it's going into the air. So what they do is they basically squeeze into these smaller tubes, and that's just to maximize the heat transfer. And you'll see in 90% furnaces, this is something that they do to an extreme to really maximize, you know, they just want to suck up all that heat out of the heat exchanger just to maximize the total amount of heat that you're pulling from the combustion process. So this is the serpentine. The reason why they call that is because it snakes through like a snake, you know, serpentine, serpent. Not exactly sure where that word came from, but I'm sure you could look it up online. But I do know it has to do with the fact that it's kind of snake-like. And even the tubular heat exchangers, which is the next type, also kind of follow this design. Now basically what this is this two pieces that are stamped, you know, one side of the tube, squish it together. Kind of like a clamshell, the only difference is it actually has this space. The clamshells were just two big open spaces, and you put the burners right in. So, but let's show you what a tubular looks like. So this right here is a tubular heat exchanger off of an 80% furnace. I believe it was off of a package unit. But you can see here it does still kind of keep that snake-like shape, right? And that's because it's a coil, you know. We want to use that to maximize our surface area. Because if we just had like one massive tube, you know, and you have all that air, it's not touching a lot of it, so you're not going to be maximizing your heat transfer. Now, all of them pretty much look like this, but you know, some of them have little differences depending on the manufacturer. They do little things to maximize heat transfer. You can see here, this one's got like little ribs on all the turns. And that, I think, is just actually to kind of reinforce it, maybe to maximize heat flow. I'm not sure exactly. I'm not an engineer. If you guys know what those are for, put them in the comments. Let everyone else know. And I would like to know, because Yeah, but I think it has something to do with the turbulence, you know, because as that hot air is going in there, it's probably got to swirl around when it hits these elbows. So maybe this kind of, you know, kind of keeps that down to a minimum. That way it's more even flow. You can see this one, they've actually connected two different pieces. There's actually a seam here. Some of them are just all one piece. It just kind of depends on the manufacturer. I believe this one's off of a Goodman. I'm not 100% sure which one this was off of. But yeah, so all tubular heat exchangers are all pretty much the same, you know, pretty much the same with slight differences depending on the manufacturer. So let's show you a 90% heat exchanger. So this right here is a 90% heat exchanger, but this is a serpentine style. So when it comes to the 90% heat exchangers in an upflow configuration, your burners are going to be on the top and your inducer is going to be on the bottom, generally speaking. And that's just because of the way they work. As you can see here, it's a little bit different shaped. Again, the manufacturers are all a little different. Some of them will actually just be like the last one I showed you, the 80%er. This particular one, you can see it kind of goes this way. This one I believe is off an American standard. So basically your burner's here, this is your combustion chamber, right? And it's gonna snake through. Now this top heat exchanger here, this is what's called the primary heat exchanger, okay? So it's the standard heat exchanger just like you're used to on an 80%er. But then on this particular one here, there's a collection box right here on the front. You've probably seen it, it's got like a bunch of insulation, it's got like a white insulation thing over it. And basically that heat's gonna come out of these holes right here, and it's gonna fill up that box and then go through this hole, which takes it through this tube, into this transfer box down here at the bottom, which is made out of stainless steel. And then it goes into these little tiny tubes at the bottom, which is considered, this is what you call the secondary heat exchanger. Or you could call it a condenser because it's a condensating heat exchanger. So in here you can see you have a bunch of little tiny tubes, and then they put fins on it to expand that surface area to maximize heat transfer. So whatever heat is left over after the primary, the secondary heat exchanger is going to suck up the last of it, and by squeezing it into smaller tubes and maximizing your surface area. Right? Now, because you're doing that, the temperature of your exhaust has dropped drastically because you've pretty much sucked up all the heat. These things can go up to 98%. So they're 90 to 98%. So that means you got 90% of your heat going into the home, 10% out the exhaust, or you can have up to 98% in the home with only 2% heat loss. That's crazy, right? Now, because the exhaust temperatures are so much lower, any moisture in there, because one of the products of combustion is moisture, right? Because you have moisture in the air, and when you're burning, you're going to be vaporizing any moisture in the air, right? And as it gets cold, it's going to condensate and it's going to collect inside here. That's why you have an entire drainage system, because it'll condensate in the secondary heat exchanger and then it goes in through a drainage system to get rid of it. Okay? Now that's also why our exhaust pipe is made out of PVC, because, you know, it's watertight. And because the exhaust temperature is so low, we can use the plastic pipe, because if we hooked up a plastic pipe to like an 80 or 80%er or a 60%er, oh man, it would melt. So, but that's why they use that, is because it can hold water, because you can use it as a drain, right? And the temperature of the exhaust is not that hot. I think it's under 100 degrees. But because of that lower temperature, any moisture that's vaporized in that exhaust stream is going to go ahead and condensate back into a liquid. And that's why it's very important that your exhaust pipes are pitched downward. That way, if any condensation happens within the exhaust pipe, it can just run back into the drainage system. Otherwise, it gets trapped, and then it can cause a restriction in the exhaust. So this right here is also a 90% heat exchanger, but this is a tubular style. So you have your primary heat exchanger, which is your standard tubes, right? Your combustion chamber here snakes through, goes into this transfer box in the back, transfers it over to the secondary heat exchanger, runs through the tubes, and then you have the water collection box here. Now, a lot of them, this box right here will actually be on the front side, so usually you have the inducer mounted directly to it. This particular one, they just put it behind the plate. As you can see here, usually you'll have that big black box right here on the front. Right there, that little circle, that's where the inducer hooks up to. Now, one thing to look for when you're dealing with the second 90% furnace in general that has a secondary heat exchanger like this is if you ever have a situation where you have a high limit trip constantly, you check the filter, it's clean, the blower's running, the evaporator coil is clean, guess what? This could actually get plugged up because it's a coil, right? So basically you would pull your blower out, stick your head in there and look, and you'll see this completely plugged, and that can be a cause for a high limit trip. So you just take your little brush and just whoop whoop, comes right off. So let me show you Carrier's older secondary heat exchanger style, and we'll use that as an example of what can go wrong with a 90% heat exchanger. So this is a Carrier older style 90% heat exchanger. So I think they've switched it over to your standard tubular, because this one seems to have a lot of issues. I'm not 100% sure if they're still using it or not. I really hope they're not, because it's a terrible design. Some points of it are terrible, but anyway. So basically you have your secondary here, which is extremely heavy. If you ever have to change one of these, it sucks. If you ever have to replace a heat exchanger, you have to order all the parts separate. So you have to order the front plate, the back plate, the transfer box, everything separate. Even these right here, this is our primary, you have to order them individually. So if you have like 5 of them, you have to get 5 of these, and you have to reassemble this whole thing. I think I have a video, I'll link it, where I've actually had to change one of these. So this is the primary heat exchanger. You can see it's a standard serpentine heat exchanger. It's a little different though. You notice you have your combustion chamber here. This is where your burners go in, but then it exhausts in the back, and that's because it's going to exhaust into that collector box in the back. I don't have one right now. I don't have a complete one because, like I said, they come in pieces. But anyway, this is Carrier's idea of a secondary heat exchanger. It's extremely heavy. So you can see here there's no fins. It's basically these little thin plates, and I'll show you the back of this. But basically what ends up happening is after you've removed all the heat from the primary, the air will move through this and it will suck up the last of the heat. Now, I must say that this style is super efficient. It's pretty hardy, but there's some trade-offs to that. So it's, as far as heat transfer goes, when they're brand new, they're great. They work really well, but they have problems. And this is one of the reasons why I don't like 90% heat exchangers. I don't like the fact that they condensate. I don't like the fact that you have water, because if you have improper combustion, it produces a lot of nasty stuff which gets stuck in said water and gets stuck in the secondary heat exchanger, because these things never drain 100%. There's always some water in there. So what happens if you have acidic stuff in the water sitting in this heat exchanger? You get secondary heat exchanger rot. As you can see here, there's quite a bit of rusted out points. Let's get a close-up of that. So as you see here, you can see that it's rotted out. And this is because you had improper combustion, which produced a lot of nasty stuff, acidic stuff, and it sits in the water because, like I said, these things don't drain 100%. And so what ends up happening is it starts to eat away from the inside out. So this is obviously a compromised heat exchanger. Now another thing too is where the transfer box goes, that's where the hot air from the primary will enter the secondary. So here it is. You can see it is completely nasty. And this is a fact that this unit was not properly commissioned. So when you install a new unit, you can do a startup, which is one thing, and then you also do a commissioning, which is another thing. They're not the same. Startup, you turn it on, everything comes on, it works, you're good to go. Commissioning, you start it up, you actually check the gas pressure, you do combustion analysis, you check your refrigerant, all that stuff. Make sure everything's good, then you call it commissioned. This was not commissioned. The gas pressure was off, which means your fuel to air mixture was not proper, which gives us improper combustion. We still have combustion, but not proper. So it's dirty combustion. You get a lot of nasty stuff like sulfur dioxide and a bunch of other nasty stuff. Now think about all that stuff is just sitting in water, and you can see that these little holes here, they're pretty thin. So as this guy started to deteriorate, all that stuff starts to plug it up. So the problem with this one is we had severe rollout, and what happened was the secondary heat exchanger was completely plugged. So it had stoppage, and this is why this is a bad design, because these holes here are so small. At least with the regular one, it's a big tube, so it's not going to plug it up. What happens is as this was running, it was plugged up, the moisture gets stuck in there, it doesn't drain out properly, so this whole thing just gets full of water. And then it just deteriorates even more until it actually eats its way all the way through, and you start getting stuff like this. So this is why I don't like this particular design on the Carrier ones, and I think that's why they're starting to move away from this design. But like I said, as far as heat transfer goes, they work really well, because you can see in there, that's a lot of surface area. You know, and each individual one of these has all that heat inside, so you're really maximizing that heat transfer. But as far as longevity goes, unfortunately a lot of people don't install these things properly, so you get a lot of this going on, and I'm sure they're well aware of it, but you know, they can't control what people do when they install these. So let's move on to another heat exchanger. So what are some of the things that we're looking for when it comes to heat exchangers? Because they can go bad. They don't last forever. Nothing man-made lasts forever. Okay. Now, generally these things should last quite a few years, but if they're not installed properly or there's some issue, that can cause them to fail a lot earlier. Okay. One of the major issues that causes these to fail is overfiring. So that means your gas pressure isn't set properly. So they just burn too hot. And these are designed to have, you know, a lot of heat moving through them, but it's spread out. So over a course of time, all that heat is going to cause it to fail. But it should take years, you know, lots of years. Like you should at least get 10 years out of a heat exchanger. Anything lower than that, you probably have your returns too small, or the homeowner wasn't changing their filters regularly. You got a dirty blower, airflow problems. Could be a lot of different things. But what we're looking for is we want to make sure that we don't have a compromised heat exchanger. So what is a compromised heat exchanger? Well, a compromised heat exchanger is generally going to be a hole or a crack. So the main point of this thing is to keep all your combustion gases isolated from your airstream. If this becomes compromised where a hole forms or a crack, that means that those gases could possibly get into your airstream, and now you're breathing it in your home, and now it becomes a potential hazard. Find a compromised heat exchanger. Generally, depending on your state or your country, you're going to shut it off and tell the customer, okay, you have two options. You can replace the heat exchanger, or you can replace the heater. So who tells us that we have to, you know, change our heat exchanger? Well, here in the US, we have the American Gas Association. They're pretty much the ones who like approve all the gas-fired appliances, make sure, you know, it's all, you know, meets all the standards or whatnot. Well, one of them anyways, because there's a bunch of them here in the US. But basically they say if you have a compromised heat exchanger, you have to change the heat exchanger or the entire furnace. You don't have to change the whole furnace. If you can get a replacement heat exchanger, there's perfectly fine to change the heat exchanger. So you sales guys, don't be pressuring people to replace it just because they have a tiny little crack. Also, there are some fine print when it comes to that. I'm not sure if this has changed. I've tried to find the document online because I used to have it printed out, but I don't have it anymore. But it basically, there's some fine print when it comes to cracks, like it has to be a certain size for it to, you know, constitute having to replace it. Like if it's an itty bitty tiny little crack, I think they say you want to monitor it for a minute, but it's recommended to replace the heat exchanger, because if you have a tiny little crack, it's going to get bigger. Once it's compromised, it just gets worse over time. So if you find a tiny little itty bitty one, it's going to turn into a big one eventually, you know. So honestly, if I find even a tiny little hairline crack, hey, you need to change the heat exchanger. I might not turn it off, but I will make sure they are aware, hey, there's a crack in the heat exchanger. It's really tiny. It's going to get big. I would suggest not running this unit and replacing the heat exchanger or replacing the furnace, but that's up to you. And then they'll say, no, just turn it back on. All right, cool, I told you. Sign right here that I explained to you that it's got a crack. Yep, okay, cool, on my way. Because ultimately you can't force anybody to do anything they don't want to do. But you can make the point clear and make sure you put it in writing, make sure you get a signature that they know, and you should be good. So, worst case scenario, you can have large cracks or you can have holes. So, let's show you what that looks like. I don't know if this shows up on camera, but there is a massive hole right here. So let's go ahead and get a closer look at that. Here's our massive hole on this heat exchanger. So what caused that? Well, it started off as a little crack and then just got way bigger. So obviously this was missed quite a few times. Now, when we're looking at heat exchangers, we're looking for cracks, we're looking for holes, right? Well, what's an indicator of a crack going to form? Well, as you can see here, this is the normal color of a heat exchanger. You see how it gets really dark right here? Well, that's a sign of temperature stress. This is what we call a temperature stress point. Now, even new furnaces will have them. It's totally normal. It just has to do with, it has to do with the heat moving through. Now, on these turns, this is where you're gonna see a lot of the temperature stress, and that's just because a lot of that heat's basically hitting the back of it and then turning. So you'll always see the temperature stress. Usually you're gonna see it, you know, on the bends. Now sometimes you might see little random spots here and there and everywhere, but we can see here that this guy was definitely overfiring. See how dark it is? Now usually the temperature stress is going to be pretty light, like a lighter gray, kind of like this, but you see how it's almost black? So this thing has been really overheated, so I suspect that we had some major overfiring. Probably gas pressure was too high. And basically, over time, as it was hitting that spot, this was probably a hot spot, it basically just, you know, burned a hole right through it. So when you have something like that, definitely shut off that furnace. You need a new heat exchanger, you need a new furnace, whatever. But yeah, we were able to get a new heat exchanger for this one. I think we changed the heat exchanger. Well, that's why I have it. But yeah, so that's an extreme case, okay? These are not common. Let me show you a big crack. Here's a serpentine heat exchanger. This one has some cracks. Now, you can see here, we have our temperature stress points, right? Right in the combustion area, you can see. Now, this was probably due to overfiring. Now, this particular unit, the blower motor had failed, and it kept running, right? So basically, the high limit would trip, it'd reset and run and run and run. High limit would trip, reset, run and run and run. This happened for quite a long time. And on top of that, the gas pressure wasn't set properly. So we had a lot of overheating. So you could see how dark these parts are. And like I said, usually it's gonna be on that first turn, and you'll see it sometimes on the other turns. Now if we look on the other side, we can see right here on the turn, and then we have a hot spot right here. And there is a little divot right here, and that's just to kind of maximize heat transfer. You can see that they have a bunch of them. But this was a hot spot, right? Now if we look in the middle, we can see our cracks. So you can see here, we have a crack right there forming, okay, right on the edge of that. And you can see it's completely toasted. It's all black, temperature stress like crazy. Now if we look here, we see a major crack. And this one is actually a hole and another crack. So this probably started off as a smaller crack like this. So these are extreme cases of cracks in the heat exchanger. So let me show you what a normal crack will look like. This is probably more likely what you're looking for and what you're going to see more often. These kind of cracks are pretty rare, but they are out there. But the smaller cracks are the more common ones, and they're harder to find. So you can stick a camera in here, you'll see that right away. But if it's a smaller crack, it's harder to see. This one's pretty easy to see, but let me show you what normal cracks look like. So here's our serpentine 90% heat exchanger. You can see this one has temperature stress. And if we look right here on the seam, we can see a tiny little crack. I have this circle, and you can see that's a tiny little crack. It's very subtle, hard to see, okay? That's the kind of cracks you're gonna see. Now, usually they'll be down here on a regular one, but because this is where the combustion chamber is, you can see it's right at that first bend. So generally you're gonna find them, you know, near that first bend, near the combustion chamber, because that's where the heat exchanger is at its hottest. Now you can see here, there's a tiny little crack right there. And like I said, these are the small little cracks that you're gonna find. They're very subtle. Again, you can see the temperature stress. Now, if you see a heat exchanger with temperature stress that's super dark, that's usually an indicator that it's overfiring. So you want to check your gas pressure, but at that point, the metal's already been kind of compromised, so usually that means that there's gonna be a crack. So in some cases, you might want to tell your customer, hey, You know, this thing's been overfiring. It's starting to show signs of wear. There is a potential that you could cause a crack. We're going to want to monitor this thing pretty regularly. Every time we do a service, we probably want to pull the heat exchanger and look for it. So I just mentioned pulling out the heat exchanger. So one of the things that I like to do is I like to pull this whole thing out and look at it. I would say that's the best way. You can stick a camera in there, you can pull the blower and stick your head in there, but you're going to find your cracks by pulling the heat exchangers out. Sometimes it's a pain in the butt, but you know, that's the only way to really be safe about it. And you could tell your customer, hey, your gas pressure is high, or if you notice the filter is really dirty, there's a chance that they don't change their filters regularly. That usually means that they're going to have, you know, a lot of temperature stress. So another thing too is if you have a small return, like your return's way too small for the unit, so you have like a 14-inch grill and it's like a 150,000 BTU furnace, you're probably gonna find a crack or major temperature stress. So you want to consider those things as well. But that's what we're doing. We're doing a safety inspection of the furnace, and the best way to do it is to pull the thing out and look at it. And then if you do find a crack, turn it off and recommend replacing the heat exchanger. Or if the unit's old, like super old, or it's got other issues, the customer may want to consider replacing the whole furnace and just going from there. So, but that's pretty much what you want to be looking for when you're doing these safety inspections of your heat exchanger, is you want to make sure that there are no cracks, there are no holes, because you don't want the gases in here going into your airstream. And what are the things you want to be looking for? Check for dirty filters, check for bad blower motors, check for small returns, check for any kind of airflow restriction, whether it be the ducts are too small or something like that. That can cause a heat exchanger to fail prematurely. Because like I said, these things will usually last about 10, 20 years. You know, I mean, there's still some natural draft furnaces out there that are 40 years old, not a single crack in that thing. So unfortunately I didn't have a clamshell heat exchanger to show you. But hopefully the charts kind of help you understand what they look like and how they work. So hopefully this video helps you out when it comes to doing an inspection on a heat exchanger and really understanding what they're for and what they do. But anyway, thanks for watching. Make sure you like and subscribe, comment, tell me what a horrible technician I am. Hit that bell notification and follow me on Instagram and Facebook. Thanks for watching.